Okay, I want to take a moment to do what is kind of a loose ends topic, but an important loose ends topic. This is the use of static data. This is something that is very common, actually. So basically, let's take a look at the program here. I'm going to run this. And let's say that this program was for the store manager. Let's say this is for a gift shop. We sell coin purses and candy and all that. And the store manager needs to know what kind of inventory do we have at any given time? How many items for sale total in my store do I have at any given time? Now, we only have 3 product objects here, so I could easily just add up the stock values in my head. So I have 10 of the cotton candy, 25 of the coin purse, I've got 35 products, and then another 18 would be 53 products, okay? So I've got 53 products in my whole store. So it wasn't a big deal because, that was such small volume. But if this were a real store and we had hundreds or thousands of items for sale and in the back room, in the stock room, then you can imagine it would not be possible to just add them all up quickly in our heads. So what we can do is keep track of the inventory value in the product class, okay? Now, your first instinct might be like, okay, let me do a private integer and we'll call it inventory count. This is going to represent the total items in the store. Okay, and that's fine. But here's the thing. Okay, if I were to say P0, for example, hey, cotton candy, what's your inventory count? The getter provides, we don't have a getter yet, but the getter would provide 53 because there are 53 items in the whole store. Hey, Hello Kitty coin purse, how many items, how many inventory items total? 53. If I ask Prickly Pear, how many items? 53. So there's a lot of redundancy here, right? They're all looking at 53. That's the bottom line number for the whole inventory. So it doesn't really make sense to make this run-of-the-mill instance field where each object is going to have its own copy of the 53. So you're going to have 53 like many times over in memory, where it really only needs to appear once in memory. Okay. Now these other ones, like the product name, each object needs its own copy of that because each object has its own name. The names are different. Maybe it's the coin purse. Maybe it's this candy item. It changes. Same with the price. They all have their own prices. They need their own copies of these regular instance fields. But the inventory count is different. It's all the same for whoever's looking at it. So this is a good candidate for making the data static. And what happens is when you make an instance field static, there's just one copy in memory, and they're all looking at it, and they're all looking at that number 53, and it only needs to appear once in memory, and they all share it, okay? So what we can do is generate a getter and setter just like we would any other instance variable. Let me right-click, I'll refactor, encapsulate fields. Okay, there it is. I should note here that when the field, the instance field is static, then the accessor, mutator, those are, getters and setters, these methods are also static, okay, which is fine. Okay, we're going to leave those alone. Another thing, okay, so before I go into the main program here and start playing with this, I need to think about this inventory count. So when the program first starts, I'm going to initialize this right here to 0. When the program first starts, I don't have any objects yet. And so the inventory count for the whole store is 0. Once I start creating objects, however, the inventory count is going to rise because I'm adding first 10 cotton candies. So then it's 10, and then I'm going to add the coin purses. Now I'm up to 35. So I have to be mindful about updating the inventory count as objects are being created. Now we know that for P1 or P0 at least, I used I'm still in the same example from the last video. P0 is the one object I created the proper way, we'll say, by using the parameterized constructor. So I want to make sure that I get into that parameterized constructor and update the inventory count. So the inventory count is going to be whatever it is plus the in-stock value, the quantity in stock of the object that was just created, okay? So that'll take care of P0, but I have to cover all corners here because I know with those other two objects, these were created the less desirable way with the empty first and then setting the stock value. So I need to get into this setter here. Where is that? This. Okay, I need to update the inventory count here because once we set that to the new stock value for, P1, for example, or P2, then, well, I need to account for that. So that would be whatever quantity in stock I just added. So that should do it, okay? So we'll see if that number climbs up to 53 ultimately. Okay, so let's go into the main program, the main method here, and I think what I will do is rather than, well, you know what, why don't we'll do it, we'll print that. I have some code here that we'll add. So let's see, I'm going to print it after each one here. So I'm going to squeeze in here. This is the first one. That was the cotton candy, I believe. Yeah, P0, the pickle cotton candy. So let me add this line. Let's see, I need to, okay, that should do it. So we're going to say there are X number of, well, it should be 10 at this point, at this point, okay? There are 10 items in the inventory is what it should end up saying after the pickle cotton candy. And look at this. With static data, notice I did not say P0. I don't even know if I'd be able to do that. I don't think I would. No, I can't. With static data, you don't call it, because all objects are looking at the same variable in memories. They're all sharing the same variable. So you don't call it for any one specific object, like P0, P1, P2. You call it by the name of the class itself, which is nice, actually. You don't have to worry about any specific object, just the class name, and there you have your inventory count plugged in. So let's run that. Okay, did you see? 10 items. Oh, okay. You know what? I think I would throw in a new line here. Okay, so let's do it for the other two, and we'll make sure that's working. Let's see here. And then I'll do this one too. Okay. Okay, so we went from 10 up to 35 and then up to 53. So you can see it's working. Okay, so there you have it, static data. It's certainly not the last time we'll see that, but yeah, okay.